Leetcode problem 1574. Shortest subarray to be removed to make array sorted. Yeah, so for this problem, actually we are going to cut off some part of the array in between and make the array in non-decreasing order. Let me just make a drawing. So this drawing is just for which kind of a method we're going to use. But let's just take a normal case. So the normal case, if so if there is a line, it is always increasing. So this means we don't need to cut anything. We just need to have a return of 0. Yeah, but there are some other cases. For example, this is the curve. Yeah, for all those numbers. Maybe we want to cut something in between here. Yeah, maybe we're gonna cut all the right areas. So this is still increasing. It is okay. Or maybe we're gonna cut from the right area, from here, from this point. So we're gonna cut from the left areas. So for this line, it is always increasing. So we're gonna choose the minimum of the two. Yeah, minimum of this line and minimum of this line. But this is not the optimal solution. We have to think about whether we can cut something in between. Maybe we're gonna cut something in between, in the middle, from here to here. If this point is less than and equal to this point, definitely maybe this line plus this line is going to be longer. So in our drawing, definitely it's going to be longer. Maybe it is not here, maybe it is here, and maybe it is here. Yeah, so this one is less than and equal to this dot. Yeah, so this means this part plus it means something in between, maybe here to here. This is the shortest. Yeah, so this is the basic solution of the problem. Let me just explain once again. Yeah, so we have two lines. One line is like it is always increasing, so this means we don't need to cut anything. We just need to return 0. But how can we check the line is always increasing? We're going to use two pointers. This is going to be the left pointer from 0, and the right pointer going to be from n-1. Yeah. So from the left pointer, we're going to check. If it is still increasing, we're going to shift to the left pointer. For the right pointer, if it is still increasing, we're going to shift to the right pointer. If there's an overlap for the left pointer and the right pointer, definitely this line is going to be increasing. So if it is increasing, we're going to return a 0. But for the second case, it's going to be like this. So this is the left pointer, and this is the right pointer. Yeah, so we're going to, if from the left pointer it is still increasing, we're going to shift the left pointer to this place, and we're going to shift the right pointer to this place. Yeah. Then we're going to choose the minimum of the two cuts. So we're going to cut from this point, or we cut from this point. We're going to choose the minimum of them. Yeah. So let me use this drawing to explain the calculation. So from here, this is the left pointer. Yeah. And from here, this is the right pointer. It's going to be starting from n-1. Yeah. So this is the right pointer. So if from the left pointer, it is still increasing. So we're going to still increase the left pointer until to this dot. Yeah, until to this dot. So we're gonna currently I will not use L and R. I will use I and J. So currently this dot is gonna be I. Yeah, because we're gonna always shift to the left pointer. This is gonna be I. And similarly for the right side, we're gonna always shift to the right pointer to the left. So this point is gonna be J. Yeah. Now we are sure from this part 0 to I, it's gonna always be in increasing order. So we're gonna cut from this dot. We're gonna cut from this position. Yeah, right. So we're gonna cut. So we're gonna calculate the length of the right side. Yeah. So for the next dot, actually we cut it from I plus 1. Yeah, because this is I. It is still increasing. So we're gonna cut it actually from I plus 1. So the calculation gonna be n minus I plus 1 and a plus 1. So this is gonna be the length of the right part. So after calculation, it's gonna be n minus I minus 1. Yeah, for this part. And let's just calculate about another dot. So if we cut it from this dot, so this dot is the J, and the dot before it is the J minus 1. Yeah, actually we cut it from J minus 1 instead of a J. Yeah, so this may be a little bit difficult. Yeah, but if we understand here, basically the calculations would be okay. So the calculation from 0 to J minus 1 is J minus 1 minus 0 plus 1, so it's going to be J. So the final result gonna be the minimum of the two part, right? Yeah. Now we still need to do the left part. So what left behind is that we can cut in the middle, because this is totally okay if we can cut it from the middle. If we can cut it from the middle, maybe we're gonna cut it from this dot. So we're gonna set it as L, and maybe from this dot we're gonna set it as R. So if we can cut it from this dot, and from here to here, and to here, it is still in increasing order. So definitely we're gonna calculate the distance from this L to this R. Maybe it's gonna have a minimum distance compared with this one. Yeah. So how can we calculate? We can just enumerate from the left side. So from the left side, we're gonna set a pointer L. It's gonna be started from 0, and then at the same time, we're gonna enumerate from the right side. So we're gonna use 2 pointers to solve it. So from the right side, we're gonna set a pointer R. It's gonna be starting from this J. Yeah. So L gonna always be in increasing order, and this R gonna always be in increasing order. This means it's gonna be a 2 pointer, and it's gonna in the same direction, and the time complexity gonna be O(n). Yeah. So while we enumerate from the left side, maybe we can find this dot and this dot. Maybe it is the minimum cut. So how can we calculate the final result? Yeah. So the final result, actually we cut it from L plus 1 to R minus 1, because from this dot it is always increasing, and from this dot to 0 it is always increasing. So actually we cut from L plus 1 to R minus 1. It's going to be this dot, R minus 1, and this dot, L plus 1. So the calculation is going to be R minus 1 minus L plus 1 and plus 1. So the final result is going to be R minus L plus 1. Yeah, so this is going to be the final result. We're going to choose the minimum of R minus L plus 1 with the minimum of this value, and finally we get the final result. Yeah, and this is the optimal solution. Yeah, so actually, if we think of this kind of problem, actually it's quite interesting. Yeah, so from this part, definitely it is increasing, we can choose one part, and from this part to the right side, it is always increasing, we can choose. But for our problem, actually, yeah, we can cut from anywhere. Maybe we're going to cut from the middle. In the middle, actually, maybe it is the shortest cut. Yeah, or maybe from the left or from the right, or maybe from the middle. Yeah. So definitely we are allowed to cut it from the middle, and we're going to connect them. From the middle, it may be the shortest. So in this way, we just enumerate all different cases, and we're going to get the minimum result. Yeah. Now let's just start coding. So the coding is going to be quite easier, actually, if you understand the whole process. Yeah. So we're going to set I and j. I going to be 0, and z going to be n minus 1. And the length of the array going to be, we're going to set it as n. Yeah. Now, we're going to use a while loop to check. So while I plus 1 less than n, and array I less than or equal to array I plus 1, because it is a non-decreasing order from the left side. So we're going to set it I plus 1. And similarly from the right side, so while j minus 1 more than or equal to 0, and array j is more than or equal to array j minus 1. So j gonna minus equal to 1, and we're gonna set an initial result. It's gonna be the minimum of the two values. So it's gonna be n minus I minus 1 and j. Yeah. So why the result is this? This is just the previous calculation. Because we calculated it, it is n minus I minus 1 and j. It means we cut from the the right side, or we cut the left side, and what is the length? If we cut from this dot, it's gonna be this dot to the right side. If we cut this dot, it's gonna be this dot from the left side. We just calculated the length before. Yeah. So another condition is we're gonna have a check if I normally gonna be less than j, but if I is more than or equal to j, this means definitely there's gonna be an overlap. If there is overlap, it means always increasing. So we don't need to cut anything. We're gonna directly return a 0. Yeah. Now we're gonna set a right pointer gonna equal to j. So this is gonna be the most difficult part. Yeah. So we're going to set a right pointer from the j, and we're going to enumerate the left side. So in this way, because this line is always increasing and this line is always increasing. This means we can use the two pointers to solve the problem. Because if this dot is more than this dot, definitely after this one, all those dots are going to be more than all those dots from the left side. Yeah. So this is the basic idea. So we're going to enumerate from the left side. So it's going to be I plus 1. Yeah, we just enumerate to this dot, this I. So this is 0 to I. So we're going to enumerate from 0 to I plus 1. It means we're going to take all the dots from 0 to I. Yeah. Then we're going to take the right side. So while R less than N, and we're going to take the dot. So yeah, the value from the left side, if it is more than the value from the right side, definitely we're going to update the right side. R going to plus equal to 1. Yeah. So this is just like a sliding window, a two-pointer problem. Yeah. We just need to slide the window. So if this dot is more than this dot, maybe here, we're going to always update this dot until we find a place the value of this dot going to be more than and equal to the value of this dot. So it means array R going to be more than and equal to array L, and then we're going to record the result. Yeah. So the result going to be the minimum of the result with R minus L minus 1. As we can see, the calculation going to be always a value minus another value minus 1 instead of a plus 1, because this is our calculation. Yeah. Actually, we are not just calculating that point. We just calculated the point before this point and the point after this point. This is why we can get this kind of final result. It's going to be R minus L. I'm sorry, this is not plus 1. This is a minus 1. Yeah. Yeah. So finally, we're gonna return the final result, and this is gonna be the minimum solution, minimum cut. Yeah. Now let me just run it to have a check. As you can see, it works. Now let me just submit it to check if we can pass. As you can see, we pass for all testing cases, and it's pretty fast. And this is a really good algorithm, actually. Yeah, the idea is also very straightforward. If we are giving a line, it's going to be like this. Because we are going to cut it, definitely we're going to cut it from somewhere. But we can still cut it in the middle. So this is why we're going to cut it from this dot. Maybe this line is going to be, yeah, the shortest. Or maybe we're going to cut it from this line. So maybe this line from the right side is going to be the shortest. Or maybe we're going to cut it something in between. Yeah, between maybe this dot and this dot. Maybe something in between it is the shortest, because we are not sure. Yeah, maybe you think why we're going to do this. Is this the optimal solution? Actually, it is. Yeah. So if you don't cut it like that, you just want to cut something in here, from here. Is that okay? Definitely it is not okay, because here is increasing, here is decreasing and increasing, here is decreasing and increasing. It is not okay. We want to make it always monotonic increasing. And after cut, it's going to always be in non-decreasing order. This means we must cut it. Yeah, we must enumerate from this point or this point, and then the line is going to be in increasing order, and we just need to calculate the shortest cut. Yeah. I think that's all about it. Thanks for watching. See you next time.